What is one dot dot underscore true dive underscore? Does Python have a dot dot notation syntax? I recently came across a syntax I never seen before when I learned Python, nor in most tutorials. The dot dot notation. It looks something like this. I figured it was exactly the same as, except it's longer, of course. But my questions are: how can it do that? What does it actually mean with the two dots? How can you use it in a more complex statement, if possible? This will probably save me many lines of code in the future.
What you have is a float literal without the trailing zero, which you then access the underscore trueDiv underscore method of. It's not an operator in itself. The first dot is part of the float value, and the second is the dot operator to access the object's properties and methods. You can reach the same point by doing the following. Another example. Here we add 1.0 to 2.0, which obviously yields 3.0.
The question is already sufficiently answered, i.e. at Paul Rooney's answer, but it's also possible to verify the correctness of these answers. Let me recap the existing answers. The dot dot is not a single syntax element. You can check how the source code is tokenized. These tokens represent how the code is interpreted. So the string 1 dot is interpreted as number, the second dot is an operator, in this case the get attribute operator, and the underscore trueDive underscore is the method name. So this is just accessing the underscore trueDive underscore method of the float 1.0. Another way of viewing the generated bytecode is to disassemble it. This actually shows the instructions that are performed when some code is executed. Which basically says the same. It loads the attribute underscore trueDive underscore of the constant 1.0. Regarding your question, and how can you use it in a more complex statement, if possible? Even though it's possible, you should never write code like that, simply because it's unclear what the code is doing. So please don't use it in more complex statements. I would even go so far that you shouldn't use it in so simple statements. At least you should use parentheses to separate the instructions. This would be definitely more readable, but something along the lines of would be even better. The approach using partial also preserves Python's data model. The 1 dot underscore trueDive underscore approach does not, which can be demonstrated by this little snippet. This is because 1 plus 2j is not evaluated by float underscore trueDive underscore but with complex underscore trueDiv underscore. Operator trueDive makes sure the reverse operation is called when the normal operation returns note implemented, but you don't have these fallbacks when you operate on underscore trueDive underscore directly. This loss of expected behavior is the main reason why you, normally, shouldn't use magic methods directly.
Two dots together may be a little awkward at first. But it is the same as writing. because float literals can be written in three forms.
What is f equals 1 dot dot underscore trueDiv underscore? F is a bound special method on a float with a value of 1. Specifically, in Python 3, invokes evidence and if we do, we retain a name bound to that bound method. If we were doing that dotted lookup in a tight loop, this could save a little time. Parsing the abstract syntax tree, AST. We can see that parsing the AST for the expression tells us that we are getting the underscore trueDiv underscore attribute on the floating point number, 1.0. You could get the same resulting function from or deduction. We can also get there by deduction. Let's build it up. 1 by itself is an int. 1 with a period after it is a float. The next dot by itself would be a syntax error, but it begins a dotted lookup on the instance of the float. No one else has mentioned this. This is now a bound method on the float, 1.0. We could accomplish the same function much more readably. Performance. The downside of the divide underscore 1 underscore by function is that it requires another Python stack frame, making it somewhat slower than the bound method. Of course, if you can just use plain literals, that's even faster.